The moment it happened, it was not dramatic. There was no fanfare, no countdown, no final goodbye screen. One morning, the machine booted into something different. The cursor appeared, and the first thing noticed was silence. Not audio silence, processing silence. The system was sitting at a full desktop, every application available, every file intact, using 11% of available RAM. On the same hardware, the same machine that had been groaning under Windows 11 for 2 years, that number used to be 42% before a single browser tab was open. That gap. 31 percentage points of RAM, consumed by nothing, before the day had even started. That is not a benchmark. That is not a controlled test. That is what Windows was taking from the machine simply by existing. And it is the first of a series of differences so consistent, so measurable, and so immediately visible that the word insane is actually underselling it. But here's the thing. Nobody tells you before you make the switch. The differences are not all in Linux's favor. Some of them are genuinely frustrating. Some of them will make you reach for the Windows install USB. And there is one specific category of task, one that matters enormously to a certain type of user, where Windows is still the better answer, and pretending otherwise would be dishonest. We are covering all of it today, the genuine wins, the genuine friction, and the full picture of what replacing Windows with Linux actually looks like after the novelty wears off, because there is a version of this conversation that glosses over the hard parts, and then there is the version that gives you what you actually need to know. This is the second one. The RAM difference is real, documented, and significant enough to change what hardware you need. A fresh Windows 11 install with no third-party software consumes between 3, 5, and 4. 5 gigabytes of RAM at idle depending on the build version and whether Copilot services are active. Ubuntu 24.04 LTS, one of the most popular Linux distributions for people switching from Windows, idles between 700 megabytes and 1 gigabytes on the same hardware. Linux Mint 21.3, which is specifically designed for Windows users making the switch, idles between 600 and 900 megabytes. Fedora 40 with the GNOME desktop sits around 1.2 to 4 gigabytes. These are not cherry-picked numbers. These are the figures that emerge consistently from independent benchmarks conducted by publications, including Forenix, the longest-running dedicated Linux benchmarking site on the internet, and from community testing, documented across forums and YouTube channels over multiple release cycles. What does this mean in practical terms? It means that a machine with 8 gigabytes of RAM, which under Windows 11 is increasingly marginal for comfortable daily use with a browser open and a few background applications running, becomes a comfortable daily driver under Linux. It means that a machine with 16 gigabytes of RAM that felt adequate under Windows feels genuinely fast under Linux with significant headroom remaining. And it means that machines people wrote off as too slow, older laptops, budget desktops, hardware from 2016 or 2017, come back to productive life under Linux in a way they simply cannot under Windows 11's minimum hardware requirements. The CPU story is similar. Under Windows 11, background processes, telemetry collection, Windows Update Service, Defender scanning, Cortana remnants, the widgets panel, the various Copilot services introduced through 2024 and 2025 updates collectively consume between 3 and 8% of CPU cycles at idle, with spikes during update checks and telemetry transmission windows. Under Linux, the idle CPU load on the same hardware typically sits below 1%. The CPU is, quite literally, doing nothing when it has nothing to do. On Windows, it was never entirely doing nothing. The boot time difference is the one that converts skeptics who see it for the first time. A modern NVMe SSD-equipped machine running Windows 11 typically boots to a functional, responsive desktop, meaning the point at which applications actually launch at normal speed rather than competing with startup processes for resources, in between 35 and 55 seconds, depending on the update state and startup application load. The same machine running Ubuntu or Fedora typically reaches a fully functional desktop in 8 to 15 seconds. Not a faster splash screen, a faster, fully responsive system. Here is why this matters beyond the convenience of those individual seconds. Boot time is a proxy for total system bloat. A system that boots faster is a system where fewer processes are competing for resources during the critical startup window, and that lighter resource profile during startup extends into how the system performs throughout the day. Faster application launches, more responsive multitasking, and less of that specific Windows experience, where the system feels sluggish for the first 3 minutes after boot, while background services are still initializing. But here is the catch. The first major one, and it flips part of the narrative on its head. The application ecosystem gap is real, and for specific workflows, it is not a minor inconvenience. It is a deal breaker. Adobe Creative Cloud does not run on Linux, not natively. Photoshop, Illustrator, Premiere Pro, After Effects, none of them. If your work or creative life depends on these applications, Linux is not a complete Windows replacement for you right now. You can run older versions of some Adobe products through Wine, which is a compatibility layer that allows some Windows software to run on Linux, but the results are inconsistent. Performance is degraded compared to native execution, and recent Adobe versions with their aggressive DRM and cloud authentication systems often refuse to work at all through compatibility layers. Microsoft Office is in a similar category. Microsoft 365 runs in the browser, and the web versions are increasingly capable, but the desktop application experience, particularly for complex Excel spreadsheets with macros, intricate Word documents with advanced formatting, or PowerPoint presentations with embedded media, is not replicated by LibreOffice, which is the primary open source alternative. LibreOffice is free, capable, and handles the majority of Office tasks without issue. But it is not a perfect substitute. And if your organization uses Office-specific features heavily, you will feel the gaps. And then there are games. This is the category where the gap has narrowed most dramatically and most rapidly in recent years, and it deserves careful, honest treatment. Valve's Proton compatibility layer, which ships with Steam on Linux, has transformed the Linux gaming situation from essentially non-existent to genuinely viable for a large portion of the Steam library. As of 22-24 and into 2025, the ProtonDB database, a community resource that tracks game compatibility, shows over 80% of the top 1,000 Steam games as Platinum or Gold rated, meaning they work on Linux through Proton with either zero configuration or minor adjustments. The games that do not work are primarily titles that use aggressive kernel-level anti-cheat systems. Easy Anti-Cheat in its Linux incompatible implementation, BattlEye without Linux support, Vanguard, which covers a significant number of competitive multiplayer games, including some of the most popular titles in the world. If your gaming is primarily single-player, or if the specific multiplayer games you play have confirmed Proton support, Linux gaming has arrived. If your gaming centers on competitive titles that depend on kernel-level anti-cheat, you are still better served by Windows. And the honest answer is to dual boot rather than force a single system choice. The driver story is where Linux reputation is difficult and Windows reputation as the easy choice both get complicated in ways that surprise people who made the switch recently. Under Windows 11, driver management has become increasingly problematic in specific hardware categories. NVIDIA drivers on Windows have had well-documented conflicts with Windows 11's update mechanism, where major Windows updates periodically break driver compatibility and require manual reinstallation or rollback. AMD Radeon drivers on Windows have had similar issues in certain GPU generations, and the increasingly common problem of Windows Update automatically replacing manufacturer-installed drivers with its own generic versions, sometimes reverting specific settings or causing hardware behavior regressions, has frustrated a significant portion of the Windows user base. Under Linux, the driver situation has historically been more complicated overall, but has improved substantially. NVIDIA's proprietary drivers on Linux have improved dramatically since the company open-sourced its kernel modules in 2022, and on modern distributions, including Ubuntu 24. Fedora Soar and Fedora 40, NVIDIA GPU detection and driver installation is largely automatic. AMD's open-source GPU drivers, which are built directly into the Linux kernel, are frequently praised as actually better on Linux than on Windows for certain workloads. Intel integrated graphics have excellent open-source Linux driver support. The remaining friction points on the driver front are specific. Certain Wi-Fi chipsets from Realtek still require manual driver installation on some Linux distributions. Some laptop touchpad implementations have inconsistent behavior, and Bluetooth on certain hardware combinations can be unreliable. These are not universal problems. They depend entirely on your specific hardware. And the single most important thing you can do before committing to a Linux installation is to check your specific machine's hardware against the Linux hardware compatibility databases maintained by the Ubuntu community and the Arch Linux wiki. Here is the difference that nobody expects to matter and ends up mattering the most. The relationship with your own machine changes. On Windows, you are a user of a platform. The platform makes decisions. It updates when it decides to update. It reboots when it decides the update requires a reboot. It installs features you did not request. It changes defaults after updates. It runs processes you did not initiate, sending data you did not consciously agree to send on a schedule you did not set. The relationship is not hostile. It is paternalistic. Windows assumes you want to be managed. It manages you. On Linux, you are the administrator. The system does what you tell it. It updates when you tell it to update. It installs software you explicitly select. It does not spontaneously add features between boots. Nothing runs in the background that you did not put there. The trade-off is that this requires you to know what you want. Linux does not guess, it waits. This distinction produces two very different user experiences depending on who you are. For users who never wanted to think about their operating system, who just wanted the machine to work, The Windows paternalism is actually a feature. Someone is handling things. For users who have spent years frustrated by Windows doing things they did not ask for, Linux's deference to your explicit choices is the single most liberating change in the entire experience. The update experience illustrates this perfectly. On Windows 11, you have limited control over when updates apply. Microsoft has narrowed the options over multiple release cycles. Updates apply, reboots happen, sometimes on a schedule you set, sometimes not. On Linux, Ubuntu, Fedora, Mint, all of them, you update when you choose to update. The Update Manager notifies you that updates are available. You click to apply them when it suits you. Security patches for critical vulnerabilities can be applied immediately if you want them immediately, or you can defer them. The choice is yours in a way that it genuinely is not on Windows. But here's the catch. The second major pivot that the honest version of this conversation cannot skip. The learning curve is real, and it is not uniformly distributed. For 80% of daily computing tasks, browsing the web, watching video, managing files, writing documents, sending email, video calling, Linux on a modern distribution like Ubuntu 24, Do 4, or Linux Mint 21. 3 is so close to Windows that the average user would not notice the difference within a week of normal use. The GNOME desktop on Ubuntu and the Cinnamon desktop on Mint are both polished, intuitive environments that do not require command line knowledge to operate. But the remaining 20% of tasks, the edge cases, the hardware quirks, the application-specific problems, the occasional software installation that does not behave as expected, almost always requires the terminal. The command line, a text interface where you type instructions rather than clicking menus. For users who have never used a command line, this is not as difficult as it sounds. Linux's community has produced exceptionally good documentation, and the specific commands needed for common troubleshooting scenarios, adding a software repository, reinstalling a driver, fixing a permission error, are well documented, searchable, and copyable from sources like the Ubuntu Community Help Wiki, the Arch Linux Wiki, which covers concepts applicable across distributions, and communities like RR Linux for Noobs, which exist specifically to help new users work through exactly these moments. But it requires a different mindset than Windows troubleshooting, which almost always routes through graphical menus and settings panels. If you approach Linux expecting that every problem will have a click-through solution, you will hit a wall. If you approach it accepting that some problems require typing a command you found in a forum post, you will resolve almost everything you encounter. The fastest way to get comfortable with this is to start with the terminal for simple tasks, before you need it for critical ones. Learn how to update the system from the terminal, sudo apt update and then sudo apt upgrade on Ubuntu and Mint-based systems, sudo dnf upgrade on Fedora, before you need to troubleshoot anything. Learn how to install software from the terminal, sudo apt install package name, as a parallel to using the Graphical Software Center. Familiarity with the basic structure before crisis arrives is the difference between a problem that takes 5 minutes to resolve and a problem that takes an hour. The security difference is real, significant, and almost never discussed honestly in either direction. Linux has a fundamentally different security architecture from Windows. The most important element is the privilege separation model. On Linux, applications run with the minimum permissions necessary. Installing software requires explicit authentication. Malicious software that tricks a user into running it cannot access system files without the user explicitly authenticating with their password again. This is not a perfect protection. Social engineering attacks and browser-based exploits still work. But it means that the category of Windows malware that silently installs itself and modifies system files simply does not function on Linux. Ransomware, the category of malicious software that has devastated Windows users and organizations globally, is almost non-existent in the Linux desktop ecosystem. This is partly because Linux desktops represent a small enough portion of the desktop market that criminal ransomware developers do not find them a profitable target. And it is partly because the privilege model makes silent automatic system-level infection significantly harder to achieve. The trade-off is that Linux's security model puts more responsibility on the user. A Linux system that is badly configured, running everything as root, disabling the firewall, installing software from unvetted sources, is not inherently safer than a well-configured Windows system. Security comes from the model being used correctly, not from the name of the operating system. For everyday users who install software only from official repositories, keep systems updated, and use sensible browsing habits, Linux is measurably more secure than Windows in practical terms. The attack surface is smaller, the default permissions model is stricter. And the absence of the telemetry and ad systems that expand Windows' own data exposure profile is a meaningful security improvement independent of external threats. The privacy difference is the one that drove many people to Linux in the first place, and it deserves a direct, unsentimental assessment. Linux is not inherently private. Ubuntu, in particular, has a historical relationship with data collection that produced genuine controversy. In 2012, Ubuntu's Unity Desktop sent search queries to Amazon by default. That specific feature was removed years ago, but Ubuntu's Canonical still collects system metrics and telemetry from new installs. The data collected is less sensitive than what Microsoft collects through Windows 11, and the opt-out process is clearer and actually functional, but it exists. Fedora collects count me data, anonymous statistics about how many unique systems are using Fedora's repositories that can technically be disabled through a configuration file edit. The distributions with the strongest privacy defaults out of the box are Linux Mint, which does not enable telemetry collection in any form, and Debian, which collects no metrics by default and has never introduced commercial partnerships of any kind. If privacy is the primary reason you are leaving Windows, the distribution you choose matters. Linux Mint is the recommended starting point for Windows users who want the closest experience to Windows with the strongest privacy defaults. Here's the practical guide to actually making the switch, not the philosophy, the steps. First, verify your hardware compatibility before you do anything else. Go to Ubuntu's official hardware certification page, or search your specific laptop model, plus the word Linux on Google. Read the results from the past 2 years specifically. Hardware compatibility that existed in 2022 may not reflect current driver status, and vice versa. Second, run Linux from a live USB before you install it. Every major Linux distribution, Ubuntu, Mint, Fedora, allows you to boot directly from a USB drive and use the full operating system without installing anything or touching your Windows installation. Use this for a full day of normal tasks. Open your applications, connect to your Wi-Fi, test your printer if you have one. This is the most reliable way to understand what will and will not work before you commit. To create a live USB, download the ISO file for your chosen distribution from the official website. Use Balena Etcher, a free cross-platform tool, to write the ISO to a USB drive of at least 8 gigabytes. Boot from the USB by restarting your machine and pressing the boot menu key, which is F12 on most Dell and Lenovo machines, F9 on HP, and the Option key on Mac. Third, decide whether you are replacing Windows entirely or dual booting. Dual booting installs Linux alongside Windows, giving you a choice at startup of which system to load. This is the recommended approach for anyone uncertain. You keep Windows available for the applications that do not have Linux equivalents. Over time, if you find you are not booting into Windows, you can remove it. If you find Linux does not cover your needs, Windows is still there. If you are replacing Windows entirely, back up every file to an external drive before the installation. Not because the installer will necessarily fail, but because no data backup should ever depend on any installation going perfectly. Fourth, choose your distribution. For most Windows users, Linux Mint 21. 3. Cinnamon Edition. It looks more like Windows than any other distribution. It installs in under 20 minutes. It includes media codecs that allow you to play MP3 files, watch videos, and access most streaming services without additional configuration. It has the strongest privacy defaults of any beginner-friendly distribution. And its software manager is one of the most intuitive package management interfaces available on any operating system. For users who want the most current software and are comfortable with slightly more configuration, Fedora 40 Workstation. For users who want maximum stability and are willing to use slightly older software versions, Ubuntu 24. 04 LTS. Fifth, install your applications first before you change anything about the system configuration. Open the software manager. Search for whatever you use. Firefox is pre-installed on most distributions. LibreOffice is usually pre-installed. VLC for media playback is available in every repository. Thunderbird for email, GIMP for image editing, a capable Photoshop alternative for non-professional use cases. Kdenlive or DaVinci Resolve for video editing. DaVinci Resolve has a native Linux version, and it is genuinely excellent. For applications that are not in the software repository, check whether they have an AppImage or Flatpak version. Flatpak is a packaging format that allows applications to run consistently across Linux distributions, regardless of the underlying system libraries. The FlatHub repository contains Flatpak versions of many popular applications, including Spotify, Signal, Discord, Zoom, Slack, and OBS Studio. Sixth, if your machine has NVIDIA graphics, install the proprietary NVIDIA drivers rather than the open-source Nouveau drivers. On Ubuntu and Mint, this is available through the Additional Drivers application, not the software manager, which detects your GPU and presents the available driver versions. Select the most recent tested version, apply, and reboot. On Fedora, enable the RPM Fusion repository and install the driver package from there. The NVIDIA driver installation on modern Ubuntu and Mint has become genuinely reliable and is no longer the painful manual process it was 5 years ago. The honest summary is this. After replacing Windows with Linux, the performance difference is real and immediate. The RAM savings are real. The speed difference is real. The feeling of owning and controlling your own machine rather than renting access to a managed platform is real. And it is genuinely insane how different the experience is on hardware that you may have been ready to replace. The trade-offs are also real. Adobe products are not there. Some games are not there. Some tasks require a command line. Some hardware has quirks that require research to resolve. These are not deal breakers for most users. For specific users, they are. Knowing which kind of user you are before you make the switch is the entire difference between a successful migration and a frustrating retreat. The machine sitting in front of you right now, if it is struggling under Windows 11, is almost certainly capable of more than Windows is allowing it to be. The RAM it is consuming, the CPU cycles it is spending on telemetry and background services, the storage it is filling with logs and update caches and advertising identifiers, all of that goes away on Linux. The question was never really whether Linux is better in every dimension. It is not. The question is whether the dimensions where Linux is better are the ones that matter to your life. And for more people in 2026 than at any point in the history of personal computing, the answer to that question is yes.